We have been discussing different types of angle relationships in circles, and what we are going to do in this lesson is look at finding segment lengths in circles. So changing this up a little bit from finding angles to finding segment lengths. In this first picture, what you have are two chords that are intersecting inside of a circle. So we have chord BA and we have chord CD. Notice that they're intersecting inside your circle. Each of these chords, when they're intersecting, is divided into two different segments. So chord CD is broken into CE and ED. Chord AB is broken into BE and EA. We call those segments of chords. How they relate is each segment of the chord, so for example, BE times EA, the two parts of one chord, multiplied together is equal to the two parts of the other chord multiplied together. So that is equal to CE times ED. If we look at the first example dealing with this, notice what you have. We have chords QP and ST, and we have the lengths of both segments of chord ST, that's the 3 and the 6. We have one length of one segment in chord QP. So we'll take the product of the two parts of one chord, 3 times 6, set that equal to the product of the two parts of the other chord. So this is 18 equals 9x. So that length of RP is 2. If we look at the second example, same thing. We'll take the product of the two parts of one chord, so 8 times 9. We'll set that equal to the two parts of the other chord, so x times 2x. We need to multiply. 8 times 9 is 72, equals 2x squared. From here, we'll divide both sides by 2, get that x squared by itself. So x squared equals 36. When we take the square root, x equals 6. Now, I've stressed and stressed and stressed having a plus or minus when we take the square root of this, but you have to think about what you're finding. You're finding a segment length. So if we had a negative 6, that doesn't make any sense. You can't have a negative segment length. So we only are including the positive. All right, what we need to look at next are some vocabulary terms of tangents and secants. So let's start with segment AB. Notice segment AB touches your circle in just one place. That makes it a tangent. And because it is just a line, AB is what we call a tangent segment. Just a segment that touches the circle in one place, a tangent segment. If you look at segment AD, that segment touches the circle twice. So it is a secant, but because it is just a segment, we call segment AD a secant segment. And then finally, the last part is the part of your secant segment that is outside of your circle, which is segment AC. Segment AC is what we call the external, meaning outside, the external secant segment. We will be using these vocab terms in the next few problems, so make sure that you understand what these mean. AB is a tangent segment, a segment that touches the circle in one place. AD is a secant segment because it is a segment that touches the circle in two places. And then finally, AC is the external secant segment. That is the part of the secant segment that is outside of the circle. All right, the first theorem dealing with different types of segments in chords deals with having two secant segments. Now remember, these are segments EB and ED that are segments touching the circle twice. Notice you have the external secant segments highlighted in red. The relationship that exists here is that we are going to take the external portion times its entire secant segment. So what that would be is EA, the external part, times the whole secant segment EB. So EA times EB, that's equal to the same thing on the other side, the external part times the whole secant segment. So on the other side, we would have the outside part, EC, times the whole thing, ED. So what I would like to do is jump down to the first example and use that information. So external times the whole equals external times the whole. So let's start on one side. We have the external part, which is 9, times the whole segment, so that's the 9 plus 11. That's equal to the same thing on the other side. So the external part, 10, times the whole thing. So that's 10 plus x. And then we'll use our algebra to solve. 9 plus 11 is 20, so 9 times 20 is equal to 10 times 10 plus x. 9 times 20 is 180, and then on the right side we'll distribute and solve from there. So the value of x is not 10, but 8. Is 8. I want you to stop the video and I want you to work on number 3. It's a similar type of problem, so stop the video and work on number 3. You should have gotten 8.7. I'm not going to talk through this anymore. If you have a question on this, then you need to let me know and I'll come help you with it. Outside times the whole equals outside times the whole. Okay? Now what we are going to do is look at one other theorem, and this deals with a secant segment and a tangent segment. So your secant segment is ED, your tangent segment is EA. What we are going to do is take the secant segment squared, so we're taking the length of EA and squaring it. That is equal to the external part times the whole again. So the external part, EC, times the whole thing, ED. So the secant segment squared equals the outside times the whole. So if we look down at example number 2, we can use that information. So secant segment squared, our secant segment is x, so we are going to square that. That is equal to the external times the whole. So the external part times the whole thing. That would be 4 times 4 plus 5, and we can solve from there. I'll add the 4 and the 5 for 9, and then multiply. From there, we'll take the square root. Again, because we are talking about a segment length, we're only including the positive value here. Instead of having you do the next example number 4 on your own, I'm going to do this one with you as well because it includes a quadratic, so we will have to use the quadratic formula. So I want to make sure we go through that together. So we'll start this the same. We have the secant segment squared, so that's 12 squared, and then we have the outside part, which is x, times the whole thing, so that would be x plus 10. When we go to solve this, 12 squared is 144. On the other side, we'll distribute the x, so that would be x squared plus 10x. This is a quadratic equation. There are a variety of ways to solve a quadratic equation, but what we are going to do is use the quadratic formula. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So what we need to do is we need to take this equation, I'll rewrite that down here. Before we can use the quadratic formula, though, we need to get that equation in standard form. So what I need to do is subtract that 144 to the other side so that this is equal to 0. Now, when I look at that equation, I know what my values of A, B, and C are. Hopefully this is coming back from Algebra 1 a little bit. So at this point, I'm going to take my values of A, B, and C, plug them into the quadratic equation. And then it's just a matter of simplifying. I'll first square 10, that's 100, minus, and then 4, oh, I forgot my negative for the 144. That should be 4 times negative 144. That's negative 576 all over 2. I can make that minus and negative a plus. So that's really negative 10 plus or minus the square root of 676 over 2. From here I can take the square root of 676. That's 26. And then I have two things to do. I have negative 10 plus 26 over 2. I have negative 10 minus 26 over 2. So the first one, negative 10 plus 26 is 16. 16 divided by 2 is 8. For the second one, negative 10 minus 26 is negative 36. Divided by 2 is negative 18. Remember, we're looking for a segment length. That negative 18 cannot be a length of a segment, so we just need to keep the positive 8. If you need to rewatch that entire example, then please do so. You will be expected to know how to use the quadratic formula. Alright, the very last thing that we are going to do is an example where we kind of put the two different theorems together. we need to find the values of x and y. Notice on the inside you have 2 chords. So I'm going to start off by finding the value of x, and to do that, remember, we're going to take the 2 parts, multiply them, equal to the 2 parts, multiply them. So this will be 8 times 18 is equal to 12 times x. We can multiply this out and divide. We get that the value of x is 12. So I'm going to substitute. Instead of putting an x there, I'll write my 12 in. And now we can solve for y, so we have a tangent. We'll take the tangent segment squared equal to the outside part times the whole thing. So that would be y squared equals the outside part times the entire secant segment would be 2 plus 12 is 26. Multiply 2 and 26 is 52, and then take the square root of that. We can round to the 10th. And I think I just realized I made a mistake way up at the beginning. Up here. I don't know if you caught it and are wondering why I'm calling this segment the wrong thing. This should not be the secant segment. That should be the tangent segment squared. I'm so sorry. This is the tangent segment that we are squaring. The problems are correct. I just named that the wrong thing for some reason. Equals the external part times the whole thing of the secant segment. So we're still doing EA squared equals EC times ED. I just called that the wrong name. So sorry about that.